Probability review number 1. Welcome to a set of just a few probability exercises that we're going to do in the next few lessons that help us not only review important concepts that could be on tests that you take in the near future, whether that be your state mandated math test for high school graduation, or whether that be your SAT, your ACT, your community or university, college entrance exams, lots of them will help with probability to review it. It also goes along with life. Probability is in many ways the most applicable type of math that you will do in life. Every time you get up in the day, you're chancing something. How late you sleep in, how much time you give yourself to get to work or school or wherever you're going, whether or not you speed, whether or not you end up getting that second cup of coffee. Everything is really chance in life. Whole companies like insurance are set up on the probability that people utilize the insurance, and their rates are dictated based exactly on that probability. So it's important. I'm going to be honest, there's not always situations that you're going to use the quadratic formula in life, for instance, but with the concept of probability, anytime you play a game, anytime you roll a die, you play a playing card, it's all chance based. So we're going to review probability, and probability in general is kind of fun. So it's a good way to just take a break from our intense quadratic functions and trigonometry and all the other stuff that we've been doing and talk about probability. All right, what you see in front of you is a spinner minus the spinning arrow that would normally land on one of these sections. We're going to find probability. Now, probability is, in general, pertaining to fractions. We're on bottom of the fraction, we have how many total spaces we have, and on top we have the ones that we care about. And we know which ones we care about by reading the directions in each of our problems. So number 1 says, expressed as a simplified fraction, p blue. So if we only care about the blue ones, we have a fraction where on top it's how many blue ones we have, and on bottom is how many whole little widgets we have, little wedges. Well, they're numbered 1 through 8, so I know I have 8 total wedges, and there are 1, 2, 3, 4 blue ones. So we need to simplify this fraction, as it says. We need to reduce it. For this, I have gone to a separate little reducing fraction calculator, courtesy of our friends at Calculator Soup. You can Google that. You can use another one. You can maybe even just use Google. It's totally up to you. However you do it, it's helpful to have a fraction reducer, unless you can just do this in your head. Like this one, I like this because it not only tells you what the fraction is, but it reminds you how it got there. Takes the greatest common factor of 4 from 4 and 8, divides the numerator and denominator, gives you a half. When you get that, we can put it here as our answer. Now expressed as a decimal, reminder how to turn fractions into decimals, even though this might be one you know off the top of your head. You just do the numerator divided by the denominator, and Desmos spits it out. 0.5, you can also just put 0.5. And then another helpful conversion is decimal to a percent. Because percent's always out of 100, you take your decimal and you multiply it by 100. And whatever number you get is your answer for that percent. And notice what it says here. I've had so many students over the years do this. It says, don't put a percent sign on, and then it says number 1. So even though it says 50%, the percent sign's already here. Don't put a percent here, or it's going to not be able to grade it. Only put in numbers in these blanks. When you do, congratulations, you will have gotten all 3 right, because we have the same exact problem on number 1. A few of these are going to be like this, where you're going to get free problems or free parts of problems, and then we just have some differing numbers on the other ones. Number 2, write all probabilities as simplified fractions. What is the probability of a flipped coin landing tails? Okay, there are 2 types of probability. There's theoretical probability and there's experimental probability. Theoretical is what's happening here because it doesn't give us the details of an experiment. And so we have to say, in theory, if I flipped a coin, and I assume it's a fair coin, it's got a side of heads and tails, it's going to land on one of the 2 sides, it's not going to land in a couch cushion or something. What's the probability, and probability means fraction, and it even tells you, right, all probabilities, simplified fractions, that you land tails? Well, there's one side that's heads, one side's tails, there's 2 total sides. So we don't even have to reduce a fraction. It's just 1 out of 2 that's already reduced for either heads or tails. Then it says you flip a coin 12 times. How many times would you expect it to land tails based on theoretical probability? So in theory, If I get 1/2 of the time it lands on heads or tails, if I just multiply that by how many times you flip that coin, so whatever number you have here, just transfer up there. Half of that is your answer for this one. And then we enter experimental probability. The question is, if you go out and do an actual experiment on this and you flip a coin 12 times, are you guaranteed to get 6 tails every time? Well, if you've ever done any game or any experiment, you know no. You could get all 12 heads, no heads, but more likely you'd get some number between 5, 6, 7, 3. So no. Everyone's answers should be 1/2 and no. And the only one we may differ on is this middle one, because you'd get any number here. Last time I did this, I got 44, I remember, so I know they change. All right, 3 is a helpful review of a circle. To start with the circle, we have to remember how many degrees are in a whole circle. This is another problem. You can ask Siri, you can use Google, or you can just remember simply, if I'm on a skateboard or a snowboard and I do a trick where I turn all the way around, that's called doing a what? Same thing if you do 2 half turns. Well, the full turns are called 360s. The half turns are called 180s. Remember, Tony Hawk was very famous when I grew up for doing a 900 and a Nintendo 64. Shout out, Tony Hawk's Pro Skater 2. Had really a whole video game is based on the 900, and then it got expanded to the 1080, especially for 1080 snowboarding, another 64 game. Okay, I'm going down a rabbit hole. Anyway, the point is it's 360 degrees for the whole circle. And in order to solve for x, because we know we have some fraction, notice our fractions aren't going to be the same. Last time I did this, I got 1/4. Whatever fraction you have, type that in. What's going to be the same for us is it's going to be times 360. Everyone is going to do their fraction times 360. That will give you x. So x is 120. Once you know what x is, then to find y, since the whole thing adds up to 360, we could subtract all 3, including 120, or whatever number you got, all 3 numbers to find y. So I'm going to close this in 3, 2, 1. Here we go. So I start with 360, and I subtract 105, and I subtract 70, and then I subtract what I got for x as well, and I get 65. All right, number 4. Fun fact about me, I am an avid Yahtzee player. I grew up playing Yahtzee. I sometimes play the app Yahtzee with buddies. It's quite fun. Yahtzee involves 5 different dice. Each of the dice are traditional 1 through 6. You try and roll, in theory, a Yahtzee, meaning they're all the same number. Well, this is the very simplified version of that. We have a number cube, which is the fancy math word for a die. And we have to know what's the probability of getting. Now, we could all have certain numbers here. I've got P3, you could have P1, P6, any number like that. Well, there's only one of each number on a 6-sided number cube. So we all only have one option to get a 3, one option to get a 6, one option to get a whatever, out of 6. So everyone's number 4 will also be the same. Whether it says P3, P1, P6, any of those numbers up to 6, it's going to be 1 out of 6. All right, now we get to 5 and 6. This is commonly called the 1/2 assignment, especially when I give some version of this for integrated 2, because lots of the answers are a half. And you can see now that we have 3 options. Now the numbers might change. You might have like 1, 2, and 6, for instance. Either way, we have 3 options for our numerator, and we have 6 options for our denominator. So sure enough, just like we had before, even though now we're reducing by 3s instead of 4s, you still get 1/2. So everyone's answer on 5, 3 out of 6 reduced, 1/2. And if you're not tired of 1/2 yet, see if you are after number 6. Because if I have numbers 1 through 6 on my number cube, and I say, let's denote the evens in blue and the odds in pink. The odds are 1, 3, and 5. Reminder that odds just mean if you divide a number by 2, you get a remainder. In this case, remainder 1. Evens are numbers that 2 divides evenly into. You have remainder 0. Well, you'll notice that in each of these situations, we have 3. We have 3 evens, 2, 4, 6. We have 3 odds, 1, 3, 5. So our fraction is going to be, once again, 3 out of 6. And we just learned or reviewed what that answer is over here. It's a half. So I said this is the 1/2 assignment for a reason. 1/2. Okay. I've given you about half these answers so far. That's good. If you're paying attention, you're following along, you're getting rewarded. Now, starting on number 7, though, we will have a divergence in the same way our problems are, because now we have numbers. You have some amount of red jelly beans, some amount of pink jelly beans, and some amount of yellow jelly beans on number 7. They are different numbers. Use your numbers instead of mine. But go over to Desmos and add them up. So I'm going to get rid of these circle problems. I'm going to add up my 16 red jelly beans plus my pink jelly beans and my yellow ones for a total of 40. So my first answer is 40. Then it says P red. So what's the probability that I reach in that jar and I get a red jelly bean out of 40? Well, I know I've got 16 red, 40 total. I have another fraction. I come over here. My denominator for each of these will be 40. My numerator will be how many the color is that I'm talking about. For red, I have 16. So I calculate that. And I get 2/5. Then I can just keep this fraction here and replace the numerator with, let's see, pink. I have 10. So now I'm going to replace this 16 with 10. And I calculate that. That's 1/4. And then yellow, I've got 14 yellow jelly beans. So 14 and 7 out of 20. Which color is most likely to be chosen? Well, you can do the complicated math of comparing all the fractions, turning them all into decimals especially, then looking. Or you can just scroll up here and say, oh, wait a minute. Before we turned them into fractions, I had 16 red, I had 10 pink, and I had 14 yellow. Oh, 16 is the largest number. I have the most red. So please do the same thing. Don't try and compare your fractions. Just look up to the top of your problem. However many do you have the most of, that's going to be your answer. All right, number 8. Zulima, shout out to a student of mine I had years ago with that same name. Randomly surveyed students at lunch in the cafeteria. She asks them their favorite main dish. She recorded the results in the table below. This is always so sketchy. Oh, cafeteria food in school. Tacos, common. Hamburgers, sure. Spaghetti, sometimes. Sushi? Oh, I'm not going anywhere in a 5-mile radius of cafeteria food sushi at a middle school, high school, and elementary school. I don't care. Get me away from that. Especially if I'm not in Oregon, where I live right now, but say I'm like in Missouri or somewhere in the Midwest, and I have like cafeteria frozen, flown over sushi. No, thank you. No, thank you. But 10 brave souls on this problem are they're doing sushi for lunch. All right. Add up these numbers. So 15, 10, 20, and 5 for me. Just like we did with the numbers up there before for our marble problem or our jelly bean problem. 15, 10, 20, 5, 50 total students. And then I do the same thing I just did with my fraction reducer. Now instead of 40 on bottom, I've got 50. And now I just follow the directions of the kind of food I have. So tacos, there are 15 tacos. So I reduce 15 up top. That gets me 3 out of 10. Then I've got my sushi. Oh boy. Whatever number equals food poisoning. That's going to be my answer. Guess that's 1/5. Hamburgers, 20 out of 50. I can just cancel the zeros here. Watch, it's just going to be 2/5. That's a fun little canceling fraction technique. Just fruit ninja off those zeros. Spaghetti is 5 over 50. That's going to be 1/10. All right, and then we've got this interesting one that says you have a certain amount of students at the school. Based on the survey, how many prefer hamburgers? Well, I know from my fraction that 2 out of every 5 students prefer hamburgers. So whatever hamburger fraction you have here, type into your Desmos calculator. Just make sure that these fractions match this with hamburger, and then you're going to multiply that times how many total students you have at the school. And 420, a number that has no significance ever, especially to the lives of the high school students I teach. Just a random number, 420. All right, 9 and 10. A person rolls a number cube and tosses a coin. There are blank possible outcomes. Okay, this is going to preview our next assignment, where we look at what's called the multiplication principle of counting, which simply says if you have separate items, in this case a die and a coin, and you want to know how many different outcomes there are on the combination of them, all you have to do is multiply the numbers together that are individual to get our answer. And this is one of those that we all have the same one. So we have 6 sides on a die, 2 sides on a coin. So we just have 6 times 2 of 12 possibilities for both. Again, if you're following along, you should get automatically like half of these right, and then the other ones you just have to use your numbers and reduce correctly. Finally, 10. A person chooses one cone, so you're going to count how many options you have on each of the following categories. I've got sugar or waffle. That's 2 choices. I personally prefer waffle cones. Ooh, hand-dipped waffle cones are so good. 1 scoop of ice cream, vanilla, chocolate, strawberry, or bubblegum. Don't know why bubblegum's the 4th flavor there, but that is 4 possibilities. And 1 topping, cherry, fudge, or caramel, however you say that. Either way, I'm going with hot fudge. 3 choices. So whatever numbers you have, use that multiplication principle of counting. Multiply them together, 2 times 4 times 3. Put that into Desmos. 8 times 3 for me is 24. Don't just type in 24, though, as you probably have separate numbers. 24. Okay. What a journey we have had throughout this assignment. We have reviewed so many different probability and just general concepts. Circles, spinners, dice. We've talked about sushi and jelly beans. I'm getting hungry. There it is. Probability review number 1. Done and done. Hopefully you have 100. I look forward to welcoming you back for the next probability review, where we'll get into more complicated probability and some fun situations that you can encounter when you are out in the quote-unquote everyday world. Best wishes with your day. It's an honor and pleasure to be your teacher. As always, take care. Dylan out.